Everybody got that worksheet?
I guess.
Okay, let's take a look. So last time I talked about why U substitution makes sense, what it's built on, right? Okay, so I'm not gonna redo that lecture. We're gonna jump into some specific examples. All right, let's see. All right, so I give you an example here, so just kind of remember what happens. So if we were back in section, where did we first learn actual derivatives? Chapter 3. If we were back in chapter 3, what would we have to do? Screw it. If we were before section 5.5, what would I have to do to this to be able to integrate it?
Factor.
I'd have to multiply it out. So I'd have to write x cubed plus 5 9 times. Multiply, 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 and then distribute the x squared. Do you want to do that? Okay, so this is pretty much analogous to when we learned chain rule, right? X plus 5 squared, I could FOIL that and then take its derivative. But x plus 5 to the 90th power, no. I don't want to multiply, right? So chain rule kind of gave us a shortcut. And this is integration's answer to chain rule. So it also doesn't require you. Thank you for fully waiting. Notice that the inside function, what is its derivative? The inside function, what's its derivative?
3x.
X squared. I love it. And see how I don't give a shit about the constant. Now listen, the derivative is 3x squared. It's 3x squared. But when I'm looking at an integral to see if U substitution will work, what I need is a function in there whose derivative is in there also. Do I have the full derivative in there? What am I missing here to have this? I see the x squared piece, but I'm missing a 3. But if I didn't have x squared, if I just had x, I can't give it another x. Because what's the only stuff I'm allowed to pull out and into an integral?
Constant.
As a constant. That's why constants don't matter worth shit. You have to get them there, but when you're looking to see will this work, I don't care about constants. So if I see an x cubed in, I need an x squared out. Okay, I like it. So I notice this, I need a 3, so of course outside I put a 1/3. Right? So now if I call U x cubed plus 5, du would be 3x squared dx. Yes? Is that cool? And again, why did I let u equal x cubed plus 5? Because, all right, so for right now I'm going to say because it's the inside function. But more generally, it's the function that's in there whose derivative is in there also. Okay, I like it. So what we're doing is analogous to that u squared minus v squared that we did on Monday. We're trying to get the details out of the way and just see the shape, see the form of it. So if I let u equal this, so let me let u equal this, so that's u to the 9th, right? And du is this, so I can replace this with du. Then I've just got this integral to worry about. You guys semi with me? A little bit? This is weird. And it feels like cheating on one level, but it's exactly what we did with the u and the v. We're allowed to do that because I don't. Do you know what x cubed plus 5 is? Do you know what it is? I don't know what I don't know what the x is. So let's call it u, because what do we do in algebra when we have something we don't know? We give it a letter. I don't know what x cubed is. Let's call it u. All right, what does it mean about dx? Well, du would be this. So now I know what I need to find there. And is this integral difficult? See, this step is where you let go of what came before. All the other shit, this here, doesn't matter where shit. That integral is easy, right? U to the 10th, 1 over 10, so you see why I got 1 over 3, right? Because there's a 1/3 there, 1/10 would be there. And then the very last step is put back in what u was. Because if I give you this question and you give me this answer, there's obviously something wrong. I didn't ask you a question about you. I'm not interested in you. No. Right? So the answer's got to match what the question was. I mean, I'm asking something about X. So we're going to do these together, and then I have a whole other sheet for you to have fun with in a bit. So look at this first one. I started off really nice. Is there an inside function whose derivative is in there also? Absent a constant, right? So what's the inside function?
3 and 3 was 5 plus 1.
Beautiful, like an x to the 5th. And what's the derivative of x to the 5th? Something x to the 4th, right? So do I have a function, inside function, in this case, whose derivative is basically in there also? And again, I have to make the constants show up. But just when I'm at the step of, will u sub work, all I care about is if I have an x to the 5th in, I need an x to the 4th out. Okay, so what do you want to let u equal here?
3x 5 plus 1.
Yes. Let u equal this piece. So then what's du?
15x to the 4th dx.
So I know what to put in place of 3x to the 5th plus 1. I got that covered. So far, how would I rewrite this integral? Integral, what would I put to the 6th power? What did we say this is? U to the 6th, I like it. Do I have what I need for du though? What does du say it needs?
15x.
It needs 15x to the 4th. So I have x to the 4th dx. I'm missing a 15. How do I make a 15 show up in there?
Like multiply by 15.
Yeah, if I multiply the inside by 15,
Take out 1.
And then the outside by 1.
and put on the outside 115. Which seems, on one level, like, wow. You multiply 15, you divide by 15. Well, right? But don't we do that all the time with fractions? Don't we multiply and divide by the same thing to make the fraction have a like denominator? So there are several purposes for doing something which overall means you didn't do shit. I didn't do anything. Yay, Jeff. But inside, what do I have the parts for? du, right? Don't I see a 15x to the 4th dx? Right here, there's 15x to the 4th dx. And what did we say that is? Du. So isn't that function inside the integral saying the integral of something to the 6th times the derivative of that something? Isn't that what this is saying? The integral of something to the 6th times the derivative of that something. So I just captured the form of what's there. It was the details that were in the way. I can't see what's going on. And is that integral we're now looking at, is that difficult? No. What is the integral of u to the 6th du?
1/7 u to the 6th.
Yeah.
C.
And then what was u?
3x to the 5th plus 1.
You don't have to bring the 115 back in?
Yeah.
Am I doing that again? Alright, so you gotta excuse me, that's really bad. It's really, really bad of doing that, but let's see, what's 15 times 7?
105.
Thank you. The reason I'm doing that is because I'm so focused on getting you to understand what this is. I forget this. So when you rewrite, the very first thing, I was thinking about this the other day, the very first thing when you start to rewrite the interval, put the constant immediately that you have outside. Yeah, yeah. Okay. So again, okay, learn from my mistakes. So look at part B. There's a very different function inside part B, correct? But no matter what the function is, do you see a part of it whose derivative is in there also? Do you see a function somewhere whose derivative is in there also? Yeah. So x cubed plus 1. In this case, again, it's the inside function. That's kind of like the place to start. And what's the derivative of x cubed plus 1? 3x squared. So like an x squared, right? So u sub will directly work here. There's a function in it whose derivative is in there also. Okay. So let me take a moment, because I get a feeling that some of you guys are looking at me like, please start making sense.
So then we can't always use this like when we see a product of like two things.
Say again, sir?
We can't always use this rule when we see like a product.
No, definitely not. This rule requires exactly what I just said. There's got to be a piece in the integral whose derivative is in there also. And normally, it's the inside function, and then there's an outside function that is related to the derivative of that, right? So if there would have just been an x out front instead of an x squared, does it look like our u sub will work directly? No. I keep saying directly though, don't I? So we're going to learn some tweaks, but if there was an x out front, why would that not work? Why would u sub not work?
Integral's not there. Or its derivative is not there.
Yeah, there's a function x cubed plus 1 whose derivative would not be in there also. But since it's x squared, u sub will work, right? Now we're missing a what to make it perfect? The derivative of x cubed plus 1 is 3x squared. So we're missing a 3, right? Okay. So real quick, a little side note. When we first learned chain rule itself, so what if I saw this? What do you got, John? You do it, buddy. There you go. All right. How do you know this is going to involve a chain rule when you take a derivative? Because there's an inside function, right? Okay, I like it. So, do you see how, when you take a derivative, you first identify what the inside function is, correct? Because when you take a derivative, what's going to happen? So there's the inside function. What happens when I take a derivative? What's the derivative of sine? Just give it away then. See how the inside does not change? Times. And what's that?
That's 4x third minus 7.
Yes. So now we are looking at, what if I had the integral of 4x cubed minus 7 times cosine of x to the 4th minus 7x? What if I had to do that integral? Well, what's the inside function? What's inside something else?
X to the 4th minus 7.
Is its derivative in there also? Yes, and I really, really want you to understand. These integrals where u sub works is undoing a chain rule somebody did. What always happens when we do a chain rule, we get a function times the derivative of the inside, right? Let me say this again, because I feel it. Chain rule. What is, if you had to summarize chain rule in a few words, wouldn't you say derivative of something times the derivative of the inside? Yes? That would be one way to quickly summarize what the chain rule is all about. Yes? So what kind of integral are we able to do? An integral, will I have something times the derivative of the inside? Because that would have come from a chain rule. So then I could undo that derivative. Yes? So if I had this integral, so this is doable. U sub works. In there. U sub sounds like do-it-yourself submarine service, but I won't. So what if I had this integral? Is that something we could currently handle? We couldn't do shit to this thing, right? Because it would come from sine of that shit. It would have to. The integral of this has to have sine of that shit as part of the answer. But the minute it has that, if I'm thinking backwards now, derivative, I would also need 4x cubed minus 7. And I don't. Now, I'm not saying you cannot do this integral by hand, but with what we know now, we cannot do this integral by hand. Okay. Maybe. Let's come back to this. That's why it's all about, it starts off as, what's the inside function? And I'm going to slowly work it to something more general. Right? Because it's not always that, but we already talked about this, I know, but just to bring everybody back, what's the inside function in part B?
X to the third plus 1.
And is its derivative in there also, basically? Yes. So that makes sense to call u x cubed plus 1. What's du?
3x squared dx.
Now real quick, other teachers teach this differently. They solve for dx. All right, if you like that, I'm going to try to wean you off that shit. Because that sucks, right? Right? Stop doing it. Because that leads to people thinking it's going to work more often. It's much safer, and it makes more sense. And it could just be me. Just to look at it, do I have all of that in there? Do I have enough to put du in? No, and obviously what am I missing? A 3. Because the most important thing that we need to show up is the x squared. I can't do shit if the x squared doesn't show up. So I have this covered, right? We call this u. We got that covered. X squared dx is part of what we need for du. How do I get a 3 to show up? Yeah, put a 1/3 outside. 3 outside. Let's see if Jeff remembers. All right, Jeff. Here's the official way to do this, right? You start to rewrite it. You put the 1/3. Oh, look at you go, Jeff. Integral. 3x squared dx, what is that? 3x squared dx is du. And the square root of this business is the square root of u. So let me call it u to the 1/2. Because fractional powers are the more useful form of roots. And again, I really desperately, please, these integrals say the same damn thing. They say the same thing. The first integral says, integral of square root of shit times derivative of the shit. This one says, integral of square root of shit times the derivative of shit. They say the exact same thing. Please see that. Because I understand u sub feels a little bit like cheating, it's weird. But what's important is it captures the form of that without the details getting in our way. The same way we did that difference of squares example. For the same reason, get the details out of the way. Oh, it's a difference of squares. That's easy shit. And then put the details back in. Same thing. So what is the integral of u to the 1/2? How does that work? Come on now. What's the antiderivative of u to the 1/2? The power becomes what? 3/2. And then you divide by that, which means multiply by the reciprocal of the new power. So multiply by 2/3. So the important thing when you're anti-differentiating, powers, get the new power, because that tells you what you're going to put in front. So I'm going to put a 2/3 out there. Do it right now, Jeff. I know you're going to forget. Plus. See, I love it. All right. And now what's the, I can put these together. Jeff, you're not going to have any room, dude. I'm sorry. 2 nights times u, and what was u? X cubed plus 1. To the 3/2 plus c. Holy shit, you're really zoomed in. So the U sub took the details out of the way. So I can focus on the form of it, integrate the form it's in, and then put the details back in. Now let's check this a little bit real quick. If I was going to differentiate this, wouldn't the 3/2 come down? 2's cancel, 3/9 is 1/3. Times x cubed plus 1 to the 1/2 times 3x squared. 1/3 of 3x squared is x squared times this to the 1/2, and that's exactly what it was to begin with. Maybe, I don't know. Maybe, no. Screw it all in itself. So here, help me out. This one's kind of neat. First thing I would do, let's rewrite this as cosine x to the 1/2 over x to the 1. All right. Well, this one's weird, but again, if you're not sure what to do, start with the inside function and see if it leads you somewhere good. Right? Can somebody identify, in this case, what the inside function is? X to the 1/2. It's inside a cosine, yes? I'm not saying that in general that's going to be what you need, but that's where you start. And what am I going to check then? If I think that's what I'm going to call U, I need to make sure what? Its derivative is in there too. Yes? Okay, so, and again, your guess might be wrong. And that's fine. You erase the shit, you start over again. It doesn't mean you don't know what you're doing. Because sometimes I do this, I'm like, it's not going to work. No big deal. No big deal. So let's try it. So if U is x to the 1/2, what's du? 1/2 x to the negative 1/2 dx, right? Let's write this a little differently. Isn't that 1/2 x to the 1/2 dx? Is that cool? X to the negative 1/2 would go down. Ignoring the constant for a minute, do I see that in there? Ignore the 2.
Yeah.
Do I see this in there?
Yeah.
Totally. It's completely, that's what it is. Do you guys see that? Isn't 1/x to the 1/2, isn't that in there?
Yeah.
There it is. It's just staring in the face saying, what am I missing? The 1/2. So what I have to do now to make that show up? What do I put on the outside? Good. If I put a 2 down here, I better put a 2 up here so they would cancel. So this is my little side work. And now I'm going to rewrite this integral. And again, Jeff, it's kind of nice I made this mistake repeatedly. And you're all like, yeah, we love it when our teacher makes mistakes. It's always the best. But maybe we'll all remember this better. So when you rewrite your integral, put the 2 down, integral. What is this going to be now? Cosine of u, because u is x to the 1/2, right? So it's cosine u. And what is all this?
Du.
That's du. Holy shit. And again, let me do this again. I'm going to do this again. There's no laser on you, is there? You suck. Or, you don't suck. The original integral, wasn't it cosine of something times the derivative of that something? Basically, with the little adjustment on the constant, right? Again, the form of it is that. When I make the substitution, I can attack the form and then put the details back in. That's what U sub does for us. What is the integral of cosine? That's all the question is now, right? Ignore it. Forget about all the weird shit, the square root, the du, all that shit. You got integral cosine. That's what you got. What's the integral of cosine?
Negative sine u.
That's the derivative.
Oh.
Yeah. See, that's the doing the manual in the reverse. But I'm not trying to. Trust me, it's very simple to do that, especially cosine sine. So this is 2 sine u.
Plus the.
Good. And what's the? Don't circle that, right? What do I have to do?
Should we put the substitution back in
Yeah, u is x to the 1/2. Okay. And then if you had time, you could check that, right? If I'm on a test and I finish it and I got a few more minutes, I'll first say to myself, okay, that's weird, that never happens. And then I might check some of my integral answers, right, using derivatives. Well, shit. Everybody's got this sheet, right? I think a few more people came in. Okay. All right. Now, here's the thing we have not discussed yet. There's several things we haven't discussed yet. But the big one is, what kind of intervals are these? These are indefinite intervals. All right. Can somebody tell me, did I say it here? No, I didn't. Good. Somebody tell me, in this interval in the example, what does the 0 and the 1 mean?
0 is it's taking the error from 0 to 1.
Be more specific.
Algebra function as well.
Okay, so not about the area, but about when you say 0 to 1, what do you mean? 0 to 1 on what axis?
Oh, the x-axis.
Okay, beautiful. So that means that the 0 and the 1 is x starts at 0, x ends at 1, correct?
Yeah.
So the original limits tell you what the original variable is doing. What are we about to do? We're about to replace the x variable with a u variable. Does the u variable have to do what the x did? No, of course not. Right? It's a whole new dude. A whole new dude. Right. So, real quick, let's do this step by step. Ignore the limits for now. First step is the same. Is there a function inside there whose derivative is in there also? Well, let's see. Obvious candidate for inside function would be x squared plus 2x plus 6. Right? And if you let u equal x squared plus 2x plus 6, the derivative is 2x plus 2. Is that in there?
No. Or
Yeah,
no.
absent a constant of 2. Right? If I multiply the top by 2, don't I get that? So if it was x plus 3 on the top, that would be so evil because it wouldn't work. But it's x plus 1. I can make that 2x plus 2 easy. So the u sub works. So therefore, I do the 1/2 and the 2, right? I can see my du right there. Bam. All right, look at me double underlining and colors and holy shit. Okay, it's all new for me. And then this was u. So 1 over u squared is u to the negative 2. Okay, now, the minute I change to u, the integral limits have to be about what that variable is doing. What did we define u to be?
X squared plus 2x plus 6.
So when x is 0, u is 6. When you plug a 0 in, don't you get 6? So again, 0 and 1. That's what x is doing. Do I have x's in here now? No. So this better capture what the new variable is doing. When x is 1, plug a 1 in, I get 9. All right, we stop for a minute. Okay. So when I have a definite integral, the really nice thing is I actually don't have to go back to x. Because now I know what u is doing, I just plug those in. I think I'm going to show you an alternate method here that young Jeff used when he did this. The reason I showed this first is because it's more generally applicable. More of my colleagues accept it. Some of my colleagues might not accept what I did. But I'll still show it to you. So the only new thing, when I'm given limits on my integral, I do all this stuff here the same way. I just have to take a second to figure out what the new numbers are for u. So when x goes from 0 to 1, u goes from 6 to 9. Yes? That's all. So when I integrate this, I get u to the negative 1 divided by negative 1, right? This is where the negative comes from. Is that cool? And then I just have to plug 6 and 9 in and blah, blah, blah. Yes?
Where did the 6 and 9 come from?
Okay. if I were to integrate this without using u sub, I would put a 0 in and a 1 in, or a 1 in and then subtract what I get when I put a 0 in, because that's what x is doing. That's where the x values are.
Yeah.
Do I still have an x in my integral at this step?
No.
So what do I need this to represent? What u is doing, right? So here, that goes with these. 0 to 1 is the change in x. These have to be what u is doing. So that's what this work is right here. When x is 0, u is 6. When x is 1, u is 9. Okay, I like it. So let me immediately show you this. And again, the caveat on this method is it might not be accepted. So I was wrestling with whether or not to show you this, and I'm going to. Apparently. Do it here. Get over there. So real quick, I'm going to pick it up right here. And I'll explain to you why I like this method better. I haven't put the limits on yet. So here's what young Jeff did, and what old Jeff still does, to be honest, sometimes. I put this. I put them in little parentheses to remind me that ain't what you's doing. No, watch. Again, that's probably more generally acceptable, but I just want to show you this, just to show you an example of what I, as a math student, did to the math to make it make more sense to myself, right? Which is what you should be doing with almost everything, within reason. So the integral of this, again, would be u to the -1 divided by -1. Is that cool? Evaluated from 0 to 1. And then I put back in, what was u? What was u? X squared plus 2x plus 6, so I distribute the negative. To see if I get the same answer. See how the parentheses came off? So for me, again, if you don't quite get this, it's fine. Right? But I put those in parentheses just to tell myself that's not what u is doing. So I integrate, and then I immediately take it back to x, and now that's what x is doing. So let's see, when I put a 1 in, -1 minus 2 is -3 minus 6 is -9. When I put a 0 in, I get -6, so it'll be minus, is that cool? Right? F of b minus f of a. Is that right? So then I get 1/2 of -9 plus 6 is -3. What did we get up there? 136? Oh, Jeff, what did you do? Oh, is that even right? Good job. It's really. Oh, duh. All right. I'm so good. I'm so smart. I just like to show off my intelligence. All right, let's see if I can. Let me bring this negative out here. One thing. What did I forgot about that guy. Okay, let's try this. So I took the negative out. U was x squared plus 2x plus 6. To the -1, 0 to 1. So this would be -1/2. 1 plus 2 plus 6 is 3 is 9. So -1 minus 6 to the -1. So this will be -1/2, 1/9 minus 1/6. So this will be -1/2. 2/18 minus 3/18 is -1/18 times -1/2 is 1/36. Same answer. All right. Now, again, you can actually see a couple of things. That was easier, yes? Right? But I also didn't have to do the step where I figured out what u was, for example. So there's a little bit of give and take. So either way you want to do it, but I do kind of recommend that way. Okay. All right. So let's try these problems here, below this. So this guy, I love this guy. You would, Jeff. There's kind of an obvious inside function here. What's that? Natural log. I mean, that looks gross, doesn't it? It's about to look a lot better. So if you let u equal ln x, what's d? Yeah, 1 over x dx. Do you see 1 over x dx in there? Holy shit. Now let's do it this way, because I'm going to do our problems the u change way instead of the old Jeff way, right? Just because, again, it's more generally accepted. So I have to change the limits. When x is e, what's u? Yeah, natural log of e is 1. When x is e to the 4th, what's u?
4.
Good. Natural log of e to the 4th, natural log and e cancel, so you get 4. So what's my new integral look like now? It'll be an integral from 1 to 4. That's what my u's are doing. 1 over x dx is du. And I'm going to end up with 1 over the square root of, which natural log of x we call u. So 1 over the square root of u is u to the negative 1/2. Is that cool? U to the negative 1/2. Now that integral should not be hard. Yes, go ahead.
So you brought the u up, that's why it's negative 1.
Yeah, 1 over square root of something is that thing to the negative 1/2. So natural log of x is u, so it's u to the negative 1/2. Right? It's the square root of u put on the bottom. Bam. And what is the integral of u to the negative 1/2? What's the new power going to be? Good. So I got to divide by that, which means multiply by the reciprocal. And u is going from 1 to 4. So what's the square root? So now I'm going to plug it. Let me stop for a minute. Is that cool? The big thing students have a problem with is the minute you've done all your u substitution, and real quick on this step, if there were any x shit left in here, I've made a mistake. The integral can't, we're not in Calc 3, which is multivariable calculus. If you want to learn that, no? Okay. So you must replace all the x shit with u shit. If you don't get rid of all the x stuff, it won't work. You've made a mistake. So this will be 2 times the square root of 4 is 2 times 2 is 4. Minus 2 times the square root of 1 is 1 times 2 is 2. So I get 2. Is there a way to check this work? We can't take a derivative of 2, I get 0, right? It's not going to tell me anything. Anybody have a way to check this? Ah, yeah, you put 1 over x squared in natural log of x in y1. You do second calc number 7 integrate from e to e to the 4th, and it'll give you a 2, right? Now, it could give you a 1.99999, or it could give you a 2.00001, and that's just because the algorithm it uses isn't always perfect, but I mean, it should be basically 2. All right, let me see what time. Oh, good. Last one we'll do together, and then I'm going to unleash you on this stuff with yourself. Yay. These are all. Oh, this one's neat. All right. What do you guys think about this one? No?
Is that a, hold on, I'll think for a second. It's like a sine squared plus cosine squared equals 1. It's like one of those properties.
Maybe. It doesn't really work that way though. Do you see a function in there whose derivative is in there? Yes, I do. Because I'm crazy. What functions are in there? Sine x, cosine squared x plus 1. Isn't cosine x in there? This is a function that's being squared and having 1 added to it, so isn't cosine of x a piece of this thing? What's the derivative of cosine x?
Negative sine.
Negative sine, isn't sine x on the top? So let me ask this again. Is there a function in there whose derivative is in there also? Yes. In fact, we could be even better. Well, we can't. Don't get too excited, John. So if I call u cosine x, what is du? So what am I missing here? Well, that's easy. Bam, bam. Put a negative on the inside, put a negative on the outside, everything's happy. Let's change my, what do I need to change?
The interval.
Yeah, the interval, I like it, the limits. So when x is 0, what is u? What's cosine of 0? 1. When x is pi over 3, what is u? Say again, sorry. 1/2. There you go. I like it. And again, the way I remember is pi over 3 is closer to the y-axis. Cosine likes x, so cosine's going to be small, close to the y-axis, 1/2. If it was cosine of pi over 6, that's closer to the x-axis. That's square root of 3 over 2. Because cosine's bigger when it's closer to where it likes it. No idea how you guys are. You guys are taught SOHCAHTOA, which doesn't do shit for you, except for one little thing. Sorry. So let's see what happens. Negative integral. What are my limits now?
1.
1 to 1/2. Anybody freaked out that that kind of goes backwards? No, good. You shouldn't be. Who cares? And then what happens on the inside? What's negative sine x dx? du. And what am I going to put here? Cosine squared x would be u squared. Now here's the evil part of this. And if I gave you a problem like this, this is one of the ones I told you you didn't have to memorize, but does anyone happen to know what that integral is? It's arctangent. And that's one of the ones I didn't make us memorize. So this would be negative inverse tangent of u from 1 to 1/2. So if I did give you that problem, I would provide you with like a list of some derivative rules I didn't make you memorize. You just have to pick out the right one, right? Yes?
So for a problem like that, I would figure that the inside function would be x plus 1 because it's like inside the cosine squared. So how do you know?
No, stop. No, if x plus 1 was intended to be inside the cosine, how would that have to be written? In parentheses. That says cosine squared x plus 1. Yes. Okay. I understand though. I mean, that's what it looks like. But you got to be really careful. We know exactly what we mean, but your brain kind of lumps things together sometimes. I totally get that. Does anyone know how to handle arctangent outside of the calculator? What's the arctangent of 1/2? Well, that one you actually have to use a calculator or something. But what's the arctangent of 1? Because what do you ask yourself? Arctangent is the inverse of tangent. So you're asking yourself, what angle would make the tangent 1? Pi over 4. Yeah. So you're going to have to use a calculator for the first part. 1/2. So it'll be negative inverse tangent of 1/2 minus negative pi over 4. It'll be minus a negative pi over 4. So whatever the shit this is, we know. All right, so that one had a lot of weirdness to it. Give you this here. So I want you guys to try these out.